Okay, I'm probably going to have to yell into the mic for this to work, so if it's very loud, I apologize. So you can just configure your own settings because this mic won't reach all the way to the board. So here's the review that I promised for momentum. So let's say I've got a car traveling that way, we'll call it M1, and it's 1,000 kilograms. And I'll have M2 traveling this way, and this one is 2,000 kilograms. And they're going to collide because someone's not paying attention. And I guess green, and they're going to go off that way. It's some conglomerate mass. And instead of, in all our problems, I gave you this velocity of what this was, and you had to figure out what your givens were. In this one, I'm going to give you the initial conditions, and I want you to find the final velocity in green there. So if I have that the initial velocity in red was 13 meters per second, and in purple here I have, we'll do 10 meters per second. I want to know the final velocity, so speed and direction of what's in green. So to do that, not too bad, just extending the page here, because I know initially all of the momentum of this system, all of the momentum in the x direction came from the red, and all of the momentum in the y direction came from the purple. So I know momentum in both coordinate directions, that's always conserved. So I need to use that principle of conservation of momentum to attack this problem. So we'll go red, that I know P initial x equals P final x. So initially M1 V1 initial x direction is going to be equal to M1 plus M2, come on, in the V final in the x direction. Remember, we're looking at only x's here. So, plugging that in, so I've got 1,000 kgs times 13 meters per second. M1 plus M2 is 3,000 kgs, and I'm solving for VFX. So VFX ends up being 4.3 meters per second. Then I'm going to repeat the process for the purple in our y direction, because I know momentum initial y equals P final y. So initially it's all coming from purple, so that was 2,000 kgs times initial velocity of 10 meters per second equals, again they stick together, so it's M1 plus M2, so that's 3,000 kilograms, there we go, times V final in the y direction. And VFY equals 6.67. Alright, but that's not our final answer. That's the parts of this triangle. That's the final velocity y. And in red I had VFX. But what I'm really asking for is I want to know what that one is and the angle. So I have to be able to figure out what the hypotenuse of that right triangle is. So to figure out the hypotenuse, we'll figure that one out first. It's just a squared plus b squared equals c squared, Pythagorean theorem. So you plug in VFX was 4.3, so 4.3 squared plus purple was 6.67 squared equals green c squared. So I get that my final velocity, when they've stuck together, I'm not talking about any components, this is their overall final velocity of 7.95 meters per second, then I need to determine what this angle is. So I can just do simple trig. You all need to know how to do this. That sine theta equals opposite over hypotenuse. I now know my opposite and my hypotenuse. I get that theta, that angle, is 57 degrees. So hopefully you're able to do that. If not, you don't deserve to graduate. All right, the other thing that we talked about was being able to interpret data from a graph. So I'm going to make a little force versus time graph. Measured in newtons, time measured in seconds. And let's say that I have this graph that looks like that, and it goes all the way up to 100 newtons and some time interval of 2 seconds. I want to know what is the change in momentum from this force that acted for 2 seconds. So really what I'm asking is, what is the area under the curve? Because the area under the curve, area under curve of force versus time is impulse. And you can all figure out the area underneath the curve of a rectangle. That's 100 by 2. So the area under this curve, the impulse here, is equal to 200 newtons times seconds, or which is equal to a kilogram times a meter per second. And then if I told you that this force acted on a stationary object of mass 10 kilograms, and afterwards I want to know what is its new final velocity. Well, we're pretty safe in assuming that the mass does not change. So if there's impulse, there's change in momentum. And if an object has momentum, that means it has mass and velocity. And we know the mass isn't going to change. That just means that its velocity changed. So if I know the mass was, I said, 10 kilograms, and V initial was 0, I can use the equation that I, our change in momentum, is equal to m times V final minus V initial. I know that. That's the area underneath my curve. I know that, and I know that. So that it's going to be, plugging it in, 200 newton seconds equals 10 kilograms multiplied by V final, so that V final is equal to 20 meters per second. Okay, so that's a quick review. Make sure you're able to figure out the area underneath a curve and that you can do basic trig. I hope this recorded. I now have the mic right in front of my face so I can see that it's working. So hopefully this helps and you all do very well on this test. Enjoy your weekend. Bye.